In the previous video, we looked at the entire Lahman database, 140 years of data, and looked at the distribution of wins for teams in the history of Major League Baseball. But oftentimes we are not interested in answering statistical questions that have to do with the entire history of baseball. We are only interested in looking at individual seasons or periods of time. So what we will cover now is how to filter the data so that we are looking at just a subset of it. And we are going to work with the same data file, which is the team's data in the Lahman database, and we're going to utilize the subset function, which allows us to look at a subset of the data. And we will not just look at the number of wins or number of losses, but we will also calculate a new variable, which is a rate statistic. Remember that wins and losses are count statistics, and those are incomplete in terms of absolute values, and only rating teams based on number of wins or losses. You have to look at the winning percentage, because the number of games played in a season varies depending on what time period you're looking at in baseball. And finally, because we like to look at visual summaries of data, we will generate that using the plot function. As in the previous video, I had started with my own code that I had put together for this demonstration, and hopefully you can follow along by using the same R code that is provided to you. Now you'll notice that I have a blank console and a blank environment and a blank plot display. So I wanted to just show you how I quickly can get to the same point where I left off in the previous video with actually just 2 clicks. So what I'm going to do is, instead of running individual lines in R and hitting run, I'm going to highlight a group of lines, and I'm going to hit run, so that all of these lines run in one command. So again, I am downloading the Lahman database into a zip file into my computer, and I am able then to continue where I left off last time. So that was 1 click, highlighting all of these rows and running them one after the other. The next click that I'm going to make is only do the plot, where we were able to show the number of wins over time. And again, the issue is, if we're looking at 140 years of data, there are different baselines in terms of the length of the season. 154 games for most of the 1900s, and then 162 games in what I call the modern era, which is the present time. In the R interface, you'll remember that putting a £sign in front of a row indicates that that is just a comment. It's not considered something that's executed. It's the software ignores it. It's just really for me to keep track of what I'm doing. So I added comments to every line so that I can communicate to you what I'm trying to accomplish. So we left off here where we were looking at 140 years of data. So what I'm going to do next is use the subset function in R. And I'm going to filter. Instead of 140 years, I'm only interested in data since 1960. Why? Because this is where the number of games stabilizes at 162 games per season. And so the new variable that I'm creating is called modern era. And that equals the subset, this is my function, of the team's database. And this is the important part of it. I am only interested in data where the year ID is greater than or equal to 1960. Okay. Now, I could have applied any filter in here, not necessarily just year ID. I could have said, well, I'm only interested in the Chicago Cubs, or I'm only interested in in seasons that were a certain length, or I'm only interested in the years, right? So I could have almost put any condition here that existed in the team's database. So I'm going to run that command, and you'll see what's happened now is it's created a new variable. Instead of having 2,805 observations, instead of having that many observations like the original data source had, now I'm only looking at about half of them, 1,462. And again, if I expand this variable, you'll see that it has this new data file has all the same variables, but starting in 1960 and going to the present time. So just to double check to make sure I did not mess anything up, I'm going to view this new data file called modern era. So the command is just view parentheses and the name of that new variable. So here we have the comma separated value file displayed, and you'll see that the earliest data is in 1960, and as you scroll down you'll notice that it goes all the way to the present time. If we go to the very bottom of this, we should see I think 2015 is the most recent Lahman database that is connected to R. Okay, so now whatever we do from now on, as long as we are utilizing the modern era data file, we are only looking at data from 1960 to the present. So the next command is to generate a scatter plot of wins over time during the modern era. Okay, so what I've done is my plot function requires me to define an X variable, so this is time, so I'm interested in year ID, and remember we're looking at year ID only in the modern era database, not in the original team's database. So you could probably predict that this is going to start at 1960 and end in 2015. And then my Y variable is going to be wins for the modern era data file. So let's run that and see what it generates on the right side. As expected, beginning in 1960 and ending in 2015, and these are the number of wins for the teams across those seasons. So interesting stuff. In a lot of cases, you'll see some outliers, some teams getting a lot of wins. In other cases, you'll see some teams getting very few wins. Okay, interesting. What I'm going to do now is create a new variable called wins 1960. So it is not only the wins from the year 1960, it's basically wins since 1960. And this variable is going to be comprised of this parameter that we just plotted, modern era $W, which is the parameter that we just plotted on the y-axis. Now, what I want to point out is that I can either keep referring to this data as modern era $W or create a new variable called wins 1960. Either one is going to give me the same result, the same data. Okay, so let's run that. Okay, and you'll see that on the top right now there is a new value called wins 1960, and it's got 1,462 data points. Why so many? Well, because you have 30 teams, or actually less than that in the 1960s, but each team had anywhere between 0 and 162 wins. I'm going to create another new variable called losses 1960, and you'll see where this is going. What I'm trying to do is turn these count statistics into variables so then I can perform a calculation which is winning percentage. Okay, so let's create a variable called losses 1960, which comes from the modern era database, the L column. $L means just the L column. Create that. You'll see it pops up here. It's nice. It has the same number of observations. Again, that number can range between 0 and 163 in some cases, because some teams play an additional game during that is considered to be part of the regular season in order to get into the playoffs. Okay, so here's now where I turn two count statistics into a rate statistic. And that rate statistic, I'm going to call it winning percentage since 1960. And that is calculated as the number of wins since 1960, which is a variable that I just created 2 lines ago, divided by the number of games, the games column, which exists in the modern era database, and it is column G. Okay, so let me just show you modern era database, column G. So all I'm doing is I'm taking wins divided by games in order to create a new statistic called winning percentage 1960. You'll remember then in the Lahman database, it only provides count statistics. So if we want to have rate statistics, we need to calculate them ourselves or create these calculations ourselves. So we run this line, and you'll see now that there's a new variable called win percentage 1960. Okay, and let's check it. Let's see what kind of data exists in win percentage 1960. I'm interested in the max number, the max percentage of wins since 1960. So that was just a simple command of max parentheses the name of the variable. Let's run that, and you'll see down below the maximum winning percentage for Major League Baseball teams since 1960 is 72%. Okay, that's a pretty good season. Now let's do minimum. I want to see what the worst a team has done since 1960. When I run that, the answer is 248, almost 25%. Okay, last but not least, I'm going to do a plot of the winning percentage 1960, which is a variable that I had created above, and I'm going to want to see that over time. So the plot that you see now, this is a count statistic. This is just the raw number of wins. What I'm doing in this next step is I'm looking at the rate statistic over time. So this is percentage now as opposed to raw number of wins. So let's run that and see what it looks like. Okay. Now it's got a similar look to it, but it's a little bit more fair comparison when I compare teams across decades in terms of what percentage of games they won, as opposed to how many total games they won. So I hope these commands help you understand better how R can help you very quickly filter data and look at a subset instead of the entire data set of 140 years. Only look at a window of time that you might be interested in. But again, these subset commands don't apply to just years. They apply to any criterion that you want to define. Now there's another way actually of filtering data that I want to show you very quickly. So if I go back to the modern era database, which is what I created by by using the subset function, I could also click on any particular column by using the filter option here, and you see it brings up a new field where I can enter. So say I wanted to filter on a particular year. You'll see that by clicking here I get a slide bar that allows me to select a subset of that data. Say I wanted between 1967 and 1984, for instance. Or say I only wanted to look at a particular team, like the Arizona Cardinals. I'm sorry, Arizona Diamondbacks, excuse me. Or the Boston Red Sox. Here we go. That's an easier one to find. So anything that starts with BOS comes up in this particular operation. And depending on the kind of question I'm trying to answer, there may be other criteria that could either be equals that criterion, or greater than that criterion, or less than a certain criteria, or between criteria. And that really allows us to filter the data very quickly and then be able to answer statistical questions that only look at a subset of the larger Lahman database. Not only when comparing teams, but also when comparing players or managers, or even the data in the postseason.